Analysis of first order reaction. The variation in the partial pressure of azomycin with time was followed at 600 Kelvin, with the results given below. The chemical equation is this one, and we are told that this is a first order reaction, so we are required to find the rate constant. In other words, we have to find the rate constant. So the concentration of A at a certain time t over the concentration of A at t0 or initially is equals to negative kt, whereby the k is the gradient and this k is the same k that we are looking for. So this is what we are given. We are given the pressure, we are given the time in seconds. But the partial pressure of a gas is equal to, or is equivalent, is proportional, it's directly proportional to its concentration. So this means we can also write this equation in terms of the partial pressure, whereby this P0 is the pressure at time 0 or initial time t. This is negative kt. So this P0 is this one because it's a pressure at t0 or initial time, and then this P now can be this one and so on like that. So now this equation is a straight line. It's a first order reaction. It's a straight line whereby this will be the y, or it's in the form of y is equal to, let me write mx, whereby m is the gradient, which is k, and x correspond to time t, and y correspond to this one here. So we are going to plot a graph. After plotting a graph, we will calculate the gradient, and that gradient is our k. So in order to do that, we can start from this value going to that side, or we can even start here, whichever way it's fine. But let me start here. We are going to create a table. We are going to create a table whereby we are going to introduce ln P over P0, P over P0, and then from there, this is the table, P over P0. So let me also show you how I got these values. In order to get this value, I will use ln. What is the pressure? The pressure is 10,9, because that's final and initial if we're just considering only the first part, right? And which is like ln 1, which become 0. That's how we got this part here. In order to get this one here, we use this value here. So it's ln, or let me erase and let me erase here and also erase here, and let me also erase this one. So in order to get this one here, we're going to use 7,63 7,63 and press a calculator. We get negative 0,36, and this is the value. So in order to get this one here, we do the same. In other words, this P0 or P0, it does not change now this time around, because it's the P0 is this one. It does not change, it's our P0. What is changing now is this P. It changes as time goes. It's changing. That's why it was changing as time goes. So finally, in order to find this one, we use the same procedure. Let me erase this one. Let me also erase this answer here, and then I will come here and say 2,5,9, and I press a calculator. It's equal to negative 1,44, which is this value. So from there I can plot a graph. Let's plot a graph whereby on our y-axis we are going to have ln p over p0. Let me write p over p0 here instead of just let me write ln p over p0 instead of just p over p0, because it's supposed to be ln p over p0. It's important. Yeah, it will be like this on the y-axis. And then let me insert time range. These are the time. Let me also insert the ln p over p0. It will be like this. So let me plot. That's how the plot look. So from this plot, the gradient is the one we are looking for. And in order to find the gradient, let me also erase some of the things here so that I can have a space. So gradient is the slope. Let me say S equal to S for slope. Slope is change in y over change in x. Our y is this part. This is our y. Our x is this part. So in other words, when we say change in a change in y, this means it's y final, which can be this value as our y final, minus y initial, which will be this value. In other words, in terms of change in y, is going to be negative 1,441 minus 0 divided by change in x will be this value minus this T0, which will be 4,000 minus 0. All these are in seconds because time is in seconds. So now if you press a calculator, this will be negative 3,6 times 10 to the index negative 4. So in other words, our rate constant k will be 3,6 times 10 to the index or to the power minus 4 per second. And this is the answer we are looking for.